Hello, everyone. Today in Algebra 1, we are going to talk about some different ways of collecting data and some different ways we can talk about and describe data. Um, we are kind of skipping around in our curriculum a little bit and saving things for later on. So this might be a good one for us to start with as we are embarking on this online learning journey. So that's why I thought it was probably best for us to start with something that might be a little bit more familiar to us. So we're going to start today by talking about ways of measuring data. One way that we can measure data is with something called measures of central tendency. You've probably heard of these as called mean, median, mode, and range. So anytime you see anything about measures of central tendency, it's talking about mean, median, mode, and range. Now you are familiar with these. We know from past experience that the mean is also known as an average. And to get an average or a mean of data, you're going to add all of your data, and then you're going to divide by the number of data values that you have. So if you have 10 numbers in your data, you're going to add all 10 of those numbers, and then you're going to take that sum and divide by 10. Okay, so you're going to add all your data and divide that sum by the amount of data values that you have. The median we know is the middle number. Now, it's really important that when you find a median that you arrange your numbers from least to greatest. So anytime we have to find a median, we need to make sure our data is in order from least to greatest. It is the number in the middle. If there happens to be an even amount of numbers in the data, then you're going to get the average of the two in the middle. So you're going to take those two that are in the middle after you've arranged them from least to greatest, and you're going to divide by 2. The mode is the number that you see most often in your data. There can be more than one mode, or there could be no mode. So the mode is the one you see the most often. And the range is going to be your highest number minus your lowest number. So it's the difference in the highest number in your data and the lowest number in your data. So let's just practice seeing a few examples. Here's a set of data. We got the numbers 13, 19, 16, 31, 25, 22, 20, 30, 19, and 21. So if you would like to work these with me, that would be a great idea. Pause the video and you can copy those down. The first thing that I would do is I would put these numbers in order from least to greatest, because I'm going to have to eventually find the median of the data. So it's going to work out better if I go ahead and put these numbers from least to greatest. I'm also getting out my calculator to help me out a little bit. So it looks like my lowest number in the data is 13. And then I'm going to underline them as I go so I know I have used them already. 16. And then I have 19 and 19. So underlining them or crossing them out as you go is a good idea, in my opinion. Then I have 20, 21, 22. And then my next highest one is 25, 30, and 31. I'm going to count and make sure I've got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So I think I'm have them all. So the first thing I'm going to find is the mean. So when you're doing your practice for me, please make sure you label for me which one you're finding. All right, so remember the mean is also known as the average. So I'm going to add all of my numbers and then divide by the amount of data that I have. So I'm going to add 13 plus 16 plus 19 plus 19 plus 20 plus 21. I'm using my calculator. Plus 22 plus 25 plus 30 plus 31. I think I have them all. So when I added all those together, I got 215. And then I have to divide by the number of data I have. And I have 10 numbers in my data. So I'm going to take 215 and divide by 10. Well, dividing by 10, I just moved one decimal place. Or you can use your calculator and you should get 21.5. So that is my mean. That is my average of all my data. Now, median is the number in the middle. Well, since I have 10 numbers, I should have 2 numbers in the middle. So when you have an even amount of data, since we have 10 numbers, you're going to have 2 numbers in the middle. So my 2 numbers in the middle looks like they are 20 and 21. Okay, because I have 4 numbers to the left of 20 and 4 numbers to the left of 21, or to the left or to the right of 21. So my median is between 20 and 21. So I'm going to take the average of those 2 numbers, 20 plus 21, and divide by 2, because there's 2 of them. 20 plus 21 is 41. Divide by 2. 41 divided by 2 is 20.5. So my median of my data is 20.5. My mode is the number that is used most often in my data. Well, I look at all my numbers, and I put them in least to greatest, so that kind of helps. And the number that I see being repeated at all is 19. Okay, so 19 is my only number that is repeated. So it is my mode. And like I said, you can have more than one mode. So if I had another set of numbers that were repeated, it could also be my mode. Or if everything is only used once, or they all use the same amount of times, then there could be no mode. Okay, but since 19 is repeated and it's my only number that's repeated, 19 is my mode. All right, last is my range. And this is going to be really simple since I have already put my data in order from least to greatest. So it's easy to pick out my highest number, which is 31. And my lowest number is 13. So I subtract 31 minus 13. And that is 18. Okay, so that's how you find a mean, median, mode, and range. And that should be familiar to us from previous mathematical experiences. All right, so continuing this video, we're going to talk about other ways to represent data. One is with a stem and leaf plot. So a stem and leaf plot, basically you divide your data into stems and leaves. So your stem is going to be your highest place value. You remember in elementary school you talked a lot about place value. And your leaf is going to be your lowest place value. Well, if I look at this data, there are some single digits in there, but most of these are 2-digit numbers, with the largest place value being in the tens place and the smallest place value being in the ones place. So I'm going to let my stems be my tens place and my leaves be my ones place. Now for these single digits, I have 8 and 8, 3 and 4, I believe are all my single digits. The stem is going to be 0. All right, and then I have some teens, so there's 1. Then I have some numbers in the 20s. Then I have some numbers in the 30s, and I think I have a number in the 40s. So those are my stems, 0, 1, 2, 3, and 4, because my numbers range from the single digits to the 40s. Okay, so your stems are going to be your highest or your most common place value, highest place value. So your least will be your second highest. So I've already underlined all of my single digits, I believe. So for my leaves, what you do is you space out the numbers for your second place value. You put them in order from least to greatest. And if they are repeated in the data, then you also need to repeat them in your table. So my lowest of my single digits, I have 8, 8, 3, and 4. I've already underlined and recognized those numbers. Then I am going to put them in order. So 3 comes first. And you just skip a pretty big space. 4, and then I have 2 8s. So 8 and 8. So just skip a big space. Okay, so those are my single digits. So I'm going to cross those out. That I've already used those. Then I look for my data that has the leading place value with a 1. They're the tens or the teens. So that would be 14, 19, 18, 14, 15, and 12. And I'm looking back over, making sure I haven't skipped anybody. So my lowest of those is 12. So I put the 2 in my leaves. And then I have, I'm sorry, I'm trying to mark it out. Then I have 2 14s. So I put 2 4s. Cross them out as I go. I have a 5 for 15, an 18, and a 19. I might stretch out my bar just a little bit. Okay, so there's the ones my teens place. Then I look for my 20s. For 20s, I have 25 and 23, and those are all my 20s. So put those in order, 23 and then 25. Mark those out. Make sure I haven't forgotten anybody. I just now noticed that I have skipped a 7 in my single digits. So I'm going to space those out then. Sorry about that. I don't know how I overlooked him. All right, so now my 30s, I have a 33, 37, and 39. So 3, 7, and 9 in order. So you want to keep them in order from least to greatest. And for my 40s, my only thing with a 40 is 42. Now I'm almost finished with my stem and leaf plot. The only thing I have left to do in my stem and leaf plot is make a key. So you know that a map always needs a key at the bottom to tell you what different shapes are, that 1 inch equals 1 mile, and all those things about a map. Well, stem and leaf plot also needs a key, because this right here, the 4/2, could mean $4.20 or 0.42 miles, or it could mean 4,200. So place value needs to be known for your stem and leaf plot. So what I like to do for my key is just give an example. 4/2 in this case meant the number 42. So a key is just an example of what the place value is talking about in your stem and leaf plot. So that is an example of a stem and leaf plot. You can also tell in a stem and leaf plot exactly how many numbers there are. So if you didn't see the original, that's the data. You can count your leaves, and that'll tell you how many numbers there are and exactly what those numbers are. So that's pretty good too. So you could find a mean, median, mode, and range from that. We can see that the highest number is 42 and the lowest number is 3, just by looking at the stem and leaf plot and not looking at the original data. Okay, I could also tell my mode probably. It looks like I have 2 modes. The only ones I see repeated are 8 and 14. So that's another good way I could see that arranged like that. And there's a lot of other things you could tell from a stem and leaf plot. All right, let's go on to the next one. A histogram. A histogram looks at the frequency of data. Okay, frequency is how often something happens. Okay, frequency is how often something happens. So if we're looking at a frequency, we're going to say how many times something fell into a certain category of ranges of data. So let's just pretend these are test grades for a class, and we want to make a histogram. And it says make a histogram comparing the number of students who made each letter grade. Well, y'all know letter grades are A's, B's, C's, D's, and F's, right? So let's just make a little table over here. Okay, so to make an A, your grade has to range between a 93 and 100, right? To make a B, your grade has to range between an 85 and a 92. Okay, just like we have in class. To make a C, your grades range from a 75 to an 84. To make a D, it's a really small window to make a D, something between a 70 and a 74. And an F is anything below a 69. So 0 to 69. Any grades between there would get you an F. Okay, so This might be a little confusing to watch on my screen, but I'm going to try to do my best. What I want to do is make a tally of every time a grade falls within a certain range. So like 71. 71 is between 70 and 74. So I'm going to put a tally over here with the D's. 85 falls between 85 and 92. So it goes with the B's. 86 goes in the same place. So does 89. So does 91. Those are all B's. 78 is a C. 83 is a C. 63 is an F. 98 is an A. 97 is an A. Whoops, sorry. 87 is a B. 78 is a C. 80 is a C. 73 is a D. 98 is an A. And 33 is an F. So I'm going to count my tallies and make sure, and I'm going to count my data and make sure that I didn't skip anybody. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I'm going to count and make sure I have 17 tallies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I've missed somebody. Well, let me start over. Y'all can fast forward through me, acting crazy if you would like to. Y'all know I make mistakes all the time. 71 is a D, 85 is a B, 86 is a B, 89 is a B, 91 is a B, 78 is a C, 83 is a C, 63 is an F, 98 is an A, 97 is an A, 87 is a B, 78 is a C, 80 is a C, 73 is a D, 76 is a C. I think that's one I skipped somewhere in there. 98 is an A, 33 is a C. All right, I should have 17 tallies now. Those are 10, 13, 14, 15, 16, 17. Okay, now I do. So pardon my mistake there. So now I have enough to draw my chart for my histogram. So draw you a axis, and you can just make the ranges down at the bottom, or since these are categorized as A's, B's, C's, D's, and F, you can do that. A's, B's, C's, D's, and F's. And this you would want to label the number of students. All right, so you want to actually want to have some numbers there. 1, 2, 3, 4, and 5 is the highest I had in any category. So for A's, I had 3 students that made an A. So I'm going to come over here and draw a bar there and make a block. Now histograms are not bar charts, so you do want to connect the bars. A B, we have 5 people that made B's, so that goes up here. We also had 5 people that made C's. We had 2 people that made D's, so that's down here, and 2 people that made F's. So that is my histogram. Now we can talk a lot about the data. So could we say that the majority of the class made a C or better? Well, we can see over here that all these students right here made a C or better on their test. So that would be pretty good. So we can say the majority of the class did well on the test compared to very few who didn't do so hot. Okay, you could also get an average from here. You can also find, you couldn't really find a range because you don't know the specific scores they made to make an F or an A, but you could find kind of if the median was an A, B, or C, things like that. So we could tell a lot about a histogram. They're pretty good for looking at like how graphs are skewed. So I can look at this graph right here. If this was your test scores, it's not, by the way, but if it was, and I could say, look, the majority of the class did well on this assignment or this test grade. So that's what histograms are used for. They're used to look at how often something happens within a range of data. All right, so I'm going to skip through here for a second because we're going to talk about those things on the next video. And the last thing we're going to talk about in this first video is a dot plot. All right, so a dot plot looks at the amount of data given for each amount given on the x-axis. You can use dots, x's. I've seen all kinds of symbols used on ACT scored. I've even seen like little trees or fish or whatever kind of data they were collecting. This one is about selling candles for a fundraiser. You know, Inquirer used to sell candles a lot, so it's something like that. So I could see little candles being used for that. They can use all kinds of things. So this is just an example. We can have an x and y axis. Basically, these would be all positive numbers, so it'd just be the first quadrant. And the first one could be number, sorry, my pen's going crazy, number of candles sold. We can sell 1, 2, 3, 4. And these could be the number of students on the vertical axis. 1, 2, 3, 4, 5, 6, 7. So I can see it. I've seen it with dots. I've seen it with X's, all different things. I'm going to use dots. So like you could have like 1, 2 people sold 1 candle. 2 people sold 3 candles. Or 2 candles. 1 person sold 3. But say they offered a prize if you sold 4 candles. So I could see that one being like a really tall number if they offer a prize, because people might not sell. If they're going to sell 3, they might as well sell 4 and get the prize, right? So, and then just an example of a dot plot. So you can find the range of the number of candles sold. You can find the average number of candles sold, because you would be a 1, 1, 2, 2, 2, 3, 4, 4, 4, 4, 4, 4, 5, 5, 6, 6, 6, and a 7. And you could list out your data that way from the dot plot. And that could help you find things like your mean, median, mode, and range. All right. So hope you enjoyed this video. So work on the practice for mean, median, mode, and range. Let me know if you have any questions. Email me anytime. I miss you guys.